Your brain doesn't work for free. This is perhaps something that we don't think about very often. When we think about why we need energy, we tend to think that after a good run or a long day building and construction, we need a sturdy meal. But actually the organ that needs the most energy in your body is your brain. Let's say you're watching a movie. You can see the images, hear the dialogue, and process what is happening in the story. For all these processes, there are certain neurons that are active in particular parts of the brain. For example, for seeing, you use the neurons in the back of your brain. The activity of these neurons use up the local resources that the brain has stored for them, such as glucose or oxygen. To make sure your neurons don't run out of resources, neurons have a BFF, blood. The blood flow in your brain is closely linked to neuronal activity. If neurons are active, the blood flow to that area increases to deliver resources. This friendship is called neurovascular coupling. Methods such as fMRI measure the blood flow and use this as a proxy for neuronal activity. So when looking at a movie, we have more blood going to the back of our brain to feed the neurons that process vision. But neurovascular coupling can also be found without a stimulus. When you're just chilling, doing nothing and not thinking about anything in particular, which we scientists call a resting state, you still have certain patterns of neuronal activity and blood flow. These patterns are called resting state networks. Cool, but who cares? Well, resting state networks are disrupted in certain conditions and diseases, such as Alzheimer's, autism, and schizophrenia. In Alzheimer's, it is so disrupted that it can actually be used as a diagnosis method. But Alzheimer's is not simple. The blood vessels in the brain are affected as well as the neurons. The whole plumbing of the brain is different, and the same goes for other diseases that affect the blood vessels, such as atherosclerosis. The question then rises, does the blood flow still give us the same insight into neuronal activity if the blood vessels are affected by vascular diseases? This is what I aim to discover in my PhD. To investigate this question, we have to monitor both neuronal activity and blood flow. But measuring neuronal activity directly in humans is difficult. This is why I want to use a mouse model in which we mimic vascular diseases. With the help of several imaging techniques, I can investigate both neuronal activity and changes in blood volume at the same time. In this way, I can see if the neurovascular coupling is maintained in the presence of vascular diseases or if the forever drops from the best friends forever. This work is important to understand the relationship between blood flow and neuronal activity, especially if we want to use blood flow resting state activity as a diagnosis tool. If we want to make statements about neuronal activity through blood flow, we need to verify if this technique can be used for all members of the population. Thank you for your attention.